Good morning. We are going to be talking about lesson 114. We did do this last week, but I want to really make sure you guys understand it because you're going to be tested on how to find points of intersection in multiple representations. And multiple representations just means on a graph, on a table, and algebraically. So first I want to start with your calculators, which I know we did not talk a lot about last week because we talked about Desmos, but it's important for ACT and SAT especially that you become familiar using your graphing calculator, okay? So the first thing I want to do is hit y equals, and under y1 I want to type the first equation in. I use this button up here for x and this one right here for squared. So 2x squared minus 5x plus 6, that's my first equation, and then y2, my second equation, negative, don't use the minus, negative 2x squared. Now we can use the minus because it's in between terms, plus 30, okay? And we want to take a look at the graph, and I can already see that my graph is kind of offset. I usually want to have, and it's actually pretty good, usually it's going to be in the standard viewing window, which is called Zoom 6, so Zoom and the number 6. And I can see the two parabolas. I know it's a parabola here because it's an x squared. I know that's a parabola because it's an x squared. The negative in front tells me it's opening down. So I can see the two parabolas, but I can see that I'm missing some stuff upwards. Left, right, and down, I feel like I have enough. Upwards is where I want to fix. So I'm going to hit the Windows button. Up is the Y, and because, again, it's up, not down, it's the maximum. So I'm going to make this bigger. I'm going to try 30 instead of 10. I'm going to see what it looks like. That one looks pretty good. Not quite. I'm going to change the window. I'm going to go to 35. That was pretty close to having the full thing. Okay? So I adjusted my window, and I can visually see the two parabolas, and I can see that they do intersect in two spots, okay? Now there's a couple ways to figure out what those two spots are. One way is to go to the table, okay? And the table is over here in blue, so I'm going to hit second graph. It will go to the table, and they only show one column for x's. The middle column is the y values for the first equation, and then the last column is the y values for the second equation. So really what I'm trying to do is see where those y values match up. And I can see right away, negative 224 are on both graphs. That is one of my points of intersection. If I keep looking down, 1329, that's not the same. That's not the same. That's not the same. That's not the same. Oh, 9 and 9 are the same. So 3, 9 and 3, 9 are on both. So from the table, okay, from the table, I probably would just show exactly what I have here, x, y1, y2, and I don't have to show a bunch of different numbers, but I do want to show negative 2, whoops, I got to put the right number in, 24, 24, okay. I'll throw in 0, just to show that those intercepts are different. Again, you don't have to put a whole bunch in. I'm going to show these. And then what I can do is highlight on my table, hey, these are where the intersections are of the two graphs. The intersections are at negative 224 and 3, 9 using the table. Okay. Now, if I go back to the graph, by just hitting the graph button, I can see, and I'm going to sketch the graph down here because I want to leave room over here for my algebraic work. If I sketch the graph, I want to include my numbers. Like I went from negative 10 to 35. Standard viewing window is negative 10 to 10. I didn't change that from X to Y at all. I'm not going to do anything super crazy. I just want to sketch. So I'm sketching this parabola. I'm sketching this parabola. Okay, I know the parabolas, they're going to have arrows. Just a sketch, okay? I tried to get the X and Y intercepts about right, okay? How do I tell on a graph? Well, obviously we're looking at the ordered pairs here and here, okay? It's the same exact equation we used for the table, so of course our answers are here, but how do I get my calculator to say this? This is like magic, okay? So if you hit, let me remember, okay, second, trace. Okay, I'm gonna write it down here, it's so important. Second, trace. It brings up all of these things that will make the calculator tell you the answer. So number 5 is intersect. I want to hit the number 5. And then it tells me down here, it asks for first curve. So I'm going to go scroll over to the left until my cursor is really close to that first place of intersection. Okay, so cursor to first intersection. Then, after my cursor is at the first intersection, I'm going to hit enter 3 times. 1, 2, 3. And it's going to tell me, so enter 3 times. And it's going to tell me right here on my screen that the intersection is at -2, 24, which we already knew, but that's one way that you can make your calculator tell you the answer. Okay, I'm going to do that one more time. So second, trace. Number 5 is intersect. This time, I don't want to get this same exact answer again. I already know that's -2, 24. I'm going to scroll over to the right until I'm close to the other point of intersection. Again, I'm going to hit enter 3 times, and it's going to just tell me 3, 9, which I know we already knew, but I need you to be able to find it on the table. I need you to be able to find it on the graph. And the way you would show it, if this was on a test, is you would show that this is -2, 24. This is 3, 9. Okay, that's the way that you would show your work using a graph. Now, the final way is how do we solve this algebraically? And we got a start in this in class last week, and we said, well, we could use the equal values method. And because I see an x squared and an x in the same equation, I actually want to get everything to the same side and set it equal to 0. So I'm going to add 2x squared to this side. I'm going to add x. And I'm going to subtract 30. Now that it's equal to 0, I can use factoring or the quadratic formula to solve. Before I do that, we talked about this in class last week. I notice all of these numbers are divisible by 4, and because it's an equation, I can just get rid of that 4 because 0 divided by 4 is still 0. Now, factoring is a little tricky here. It looks easy, but I saw some people making some mistakes. So remember, -6, because this is a 1, can go in the box, and I'm thinking of my factor pairs, so 1 times 6 and 2 times 3. Because this is negative, it means I need to have opposite signs to make a -1, okay? 6 and 1 don't work, but -3 and +2 do work. And again, we've talked about the shortcut for factoring. If this leading coefficient is 1, okay? We can just take those numbers, put them in the parentheses. If you'd prefer to use box and diamond, go right ahead. Now, we're still having to solve for x, but this is where the zero product property comes in. When two things are multiplying to make 0, one of those two things has to actually be 0, okay? One of the two parentheses actually has to be 0. Once I get it set equal to 0, I flip the 2, I flip the 3 to the other side, I get x equals -2 and x equals 3, okay? We're not quite done yet, but we've done all the hard work. This is the x value. We also need to find the y value because a point of intersection is an x and a y. So it's -2 something, +3 something. Of course, we already know the answer because we've solved this problem using the table and the graph. But if we didn't already do that, you can plug it into either of these two. You should get the same answer, 2. Remember, when there's a negative being plugged in, we need it in parentheses before we square it. -5 times -2 plus 6. Also, we need to make sure we follow the order of operations. So squaring has to come first. And when we square a negative number, it does become positive because a negative times a negative is positive. Now I can go through and multiply. 8, negative times negative is positive. Now I can add 8 plus 10 is 18, plus 6 is 24. Okay, so there's my answer, which does match what I already had, but I showed algebraically. Now for the 3, I'm going to squeeze that in here before I lose. Actually, I have room here. So I'm going to do 2 times 3 squared minus 5 times 3 plus 6. I'm going to square first. Then multiply 18 minus 15 plus 6. 18 minus 15 is 3. 3 plus 6 is 9. That's how we algebraically get negative 224 and 3, 9.